All right, you guys, we're going to wrap up Unit 1 tonight with 1.6, which is compound inequalities, okay? And same as last time in 1.5, we're going to solve, create, and graph these inequalities, okay? Compound means exactly the same as it does when you are talking about words in English. So if you have a compound inequality, that means that you are putting two inequalities together to make one, just like you do with a compound word, okay? So we're describing them first in here. So this first set, for example, 1 says, how can you use inequalities to describe the sets of numbers graphed below? So this one is saying that you need to have some number that is less than or equal to -3. Or you could have some number that is greater than 2. Now, I put the or there because it has both sides colored in. Also, it means it can go any number this direction and any number this direction forever. Then I use the symbols based on what the circles are looking like. So it's going left, so I know it's less than, and it's filled in, so it has to be equal to. This one's going to the right, so it's greater than, and it's open, so there's no equal to on the bottom. Okay? On this one, however, it has boundaries. So we know that this number stops at -4, and stops at 1. So the number has to be somewhere between those two numbers that are given to us. We know that it has to be bigger than -4. So x needs to be greater than or equal to -4. But compared to 1, it has to be this way, which is less than 1. So we put the x in between. We put the boundary numbers out here on the sides. And then our symbols go whichever way they are compared to x. Okay, so try to write one for this next one. We know the numbers have to be in between. So I'm going to start with x in the middle. -2 and 6 are our boundaries. X needs to be greater than -2. So greater than pointing at x. But it needs to be smaller than 6. 6 is filled in, so equal to it is. Okay? Now, solving compound inequalities with the or means that you have two separate problems to solve. One that shows you what it should be going this way, and one that shows you what it should be going this way, greater than and less than. So I'm going to solve like normal. Subtract 7. We have 5x is greater than 6. Divide by 5. And x is greater than 6/5. Or subtract 3. -4x is greater than 8. Divide by -4. And x is, flip it because we did a negative, less than -2. So our number that we're graphing needs to be greater than 6/5 or less than -2. So when it's an or, it has to be one way or the other. So it's filled in on both directions. So I'm going to draw my number line. I'm going to put -2, -1, 0, 1, and 2. Okay. Less than -2 means open and to the left. Greater than 6/5, well, that's like 1 and 1/5. So it's about here, right? I'm going to have an open circle. All right. And it's going to go to the right because it's one way or the other. So that or means both directions. Okay? Pause and do this one by yourself and then check in. So subtract 2. Negative 3x is greater than negative 9. If I divide by negative 3, I have to flip. So it's less than 3. Or distribute, and we get 2x minus 4 is greater than or equal to 6. Add 4 to both sides, and we have 2x is greater than or equal to 10. Divide by 2, and x is greater than or equal to 5. So our number needs to be either less than 3 or greater than 5. So if I do 2, 3, 4, 5, I'm going to have an open on 3. Less than would be to the left, or greater than or equal to 5, so filled in, and greater than would be to the right, one way or the other. Okay? Now, when it's between two numbers, like it has those boundaries like we talked about, okay? The problem is in the middle, and we do something a little bit different than we've done before, because we join two compound or inequalities together. So when I get ready to solve this, I need to subtract 9, but not only do I subtract it from the right, I also have to subtract it from the left, because it kind of has 3 parts or 2 equal signs basically. So negative 12 minus 9 is negative 21. We have 7x in the middle. And then 16 minus 9 gives me 7. Last step, divide by 7, which we do on all 3 parts. These are gone, and I have negative 3, x in the middle, and 1. So our answer needs to be between negative 3 and positive 1. So if I have negative 3, now I'm just going to skip, and I'm going to have 0 here, and then we'll just put 1 here, okay? So negative 3 is equal to, x needs to be greater than that, so they're going to go this way, but I have to stop at 1, and 1 is an open circle because it doesn't have an equal to. Okay, let's go to the next one. We have 2 on the bottom, so it's the first thing that has to go, times 2. But what I do to the middle, I have to do the left and the right. So these are gone, and I have 30 is less than or equal to 3x minus 3, which is less than or equal to 48. I need to add 3 to all 3 sides. These are gone, and I've got 33 is less than or equal to 3x, which is less than or equal to 51. Last step is divide, so again, divide on all 3. 11 is less than or equal to x, which is less than or equal to 17. So our number on the graph has to be between 11 and 17. So we draw our number line. I'm going to put 11, 13, 15, and 17. Then we have to start at 11, and it's filled in. It's going to be between 11 and 17, and this one's filled in. So we know we have to fill in between those two numbers. Okay, almost there. So this one, try on your own, and then come back when you're done. So we're going to add 1. divide by 7. Oops, 2. Here's my 2. Let's graph them. We have between 2 and 7. So open on 2, closed on 7, and it has to be between the 2. All right, last one. Enrique plans a diet for his dog River. River consumes between 510 and 540 calories per day. If River eats 1.5 servings of dog food each day, how many treats can she have? Okay, so the numbers we have to stay between are 510 and 540. Okay, River eats 1.5 servings of dog food each day. How many treats can she have? So we need to know if she has 1.5. Let me make some more room here. If she has 1.5 times this, because that's her number of calories per serving, they want to know, in addition, how many treats can she have at 15 calories per treat. So let me erase these two numbers here so we have a little bit more space. 510, 540, and we want them to be between these two. Okay, so if I take 1.5 times 320, I get 480. Sorry. Okay, let's subtract 480. So this should be 20. And this is 60. This would be 13 1/3. And this would be 40. Oh, I did it again. Okay, so divide by 15. Oops. 15, 15, 15. This would be 2 and 4. So River can have between 2 and 4 treats per day and still stay in the calorie range. All right. So suppose River has new treats that are 10 calories each. How many of the new treats can she have and remain in her calorie range? So same thing here. We basically just replace what we had when we started with 30. And these are going to be 10x. It was 60. Okay, so divide by 10, divide by 10, divide by 10, and you get 3 and 6.